Saliva is produced by three pairs of salivary glands, the parotid, submandibular, and sublingual glands that drain into the oral cavity. Parotid is the largest salivary gland, secretes watery fluid rich in amylase, which is around 20% of total saliva. Submandibular glands contribute to the secretion of largest portion of total saliva, which is around 70%. Sublingual gland is the smallest, secretes around 5% of saliva. Normally, these three pairs of glands produce around 1500 milliliters of saliva every day with the pH around 7, but it's slightly acidic. Lingual lipase is an enzyme in saliva which acts as a catalyst to break down saturated fats to make them easy for digestion. Salivary alpha amylase is another enzyme present in saliva, breaks starch into maltose and dextrin. Mucins are glycoproteins which aids in lubrication of the food. They bind to bacteria and suppress the actions of them, and also they give protection to the oral mucosa. Immunoglobulin A has antibacterial and antiviral action, and lysozymes attack walls of bacteria. Lactoferrin is an iron-binding glycoprotein, thus it is closely related to the antimicrobial action. Proline-rich proteins are major components of parotid and submandibular saliva, which helps in protection of teeth by stimulating enamel formation. And they also bind to toxic tannins and neutralize them, and have some antimicrobial actions as well. In saliva, inorganic substances such as sodium, potassium, bicarbonate, chloride, and gases include oxygen, carbon dioxide, and nitrogen are also present. Normally, glucose is not present in saliva, but in conditions like diabetes mellitus, it appears. What are the functions of saliva? It has several functions. Saliva aids in swallowing, speech, and smiling as it has the lubricative effect. It acts as a solvent to the molecules that stimulates taste. Due to the slightly acidic pH and antimicrobial effects, it keeps our mouth and teeth clean, maintains our oral pH around 7 and neutralizes the gastric acid. Regulation of water balance in dehydrative conditions such as diarrhea, and because of the digestive enzymes such as alpha amylase and lingual lipase, it initiates the digestion process. Primary secretion is released into acini and flows through intercalated interlobular and intralobular ducts to finally open into the main duct. Primary secretion is isotonic. Sodium, potassium, chloride, and bicarbonate are present in similar concentration to plasma. Then the secretions get modified in these ducts. Due to effects of aldosterone, sodium and chloride are reabsorbed, while potassium and bicarbonate are added into the ducts. And also, these ducts are impermeable to water. Since sodium is the major determinant of tonicity, saliva becomes hypotonic while it passes through these ducts. At low secretory rates, saliva is hypotonic because it gets more time for sodium and chloride reabsorption. Aldosterone and antidiuretic hormones modify the ionic content of saliva, but they never regulate the flow rate. Let's see how saliva secretion is controlled. Saliva secretion is mainly mediated by parasympathetic nervous system, yet it has sympathetic involvement too. Smell, taste, sound and sight of food which initiates the salivary secretion process by stimulating superior and inferior salivatory nucleus in medulla. Signals go to otic and submandibular ganglions through parasympathetic nerves and ultimately parotid and submandibular glands causes salivary secretion via effects on acina secretion and vasodilation. Sympathetic stimulation causes vasoconstriction. So, small amount of saliva is produced from submandibular glands that is rich in organic materials. Parasympathetic stimulation causes vasodilation, so it leads profuse secretion of watery saliva with low content of organic material. Acetylcholine is the neurotransmitter in parasympathetic process. After the release, acetylcholine is broken down into acetyl and choline by the enzyme acetylcholinesterase. Atropine is the muscarinic receptor blocker and acetylcholine can't bind to its receptors. Therefore, atropine reduces salivary secretion. Organophosphates inhibit the action of enzyme acetylcholinesterase, so elevation of acetylcholine leads to hypersalivation.